every time I try to start, someone joins. All right, so let's talk about hyperbola. So like I was saying before I hit the record button, very similar to ellipses. So if that made sense, a lot of the same rules that you use, like how to find the center, and then looking at the number under x squared and moving left and right, looking at the number on the y squared and moving up and down. The way you do that to graph an ellipse, same as a hyperbola. So in the first, I have these old notes that I had, that I just copy and pasted. Oh. And these are just here for your reference. I'm going to go through all this, but just if you want like one page to like walk you through how to graph a hyperbola, it's here. But I wouldn't just tune me out and then just try to figure it out on your own later. Like I'll explain what everything here means. All right, so first let's see what are hyperbola and like how they're constructed. So we know that a circle is a set of all points that are the same distance from the center. And then we saw that with an ellipse, you know, every point on the ellipse, if you find the distance from that point to each focus, the sum of those two distances would always be the same. All right, a hyperbola is like an ellipse, but it's the difference between those 2 points is always the same. All right, so let's see what's happening. All right, so I'm going to just move point C around the circle, and then it's going to trace a bunch of points, and we see a hyperbola. All right, so that's what a hyperbola looks like. It kind of looks like two parabola going left and right. All right, now they could also go up and down. So A and D are the two focuses, so the foci. If I put the foci like on top of one another, and then I move point C around, all right, that's also a hyperbola. All right, so it looks like two parabola going in opposite direction. All right, so how is this being created? All right, so let's move back to the way it was. And we're gonna do that. So if we look at A and D, all right, A and D are the focal points. All right, H1 and H2 are the points that make up our hyperbola. So notice how, oh, I gotta do something real quick. Make sure everyone's camera's off. I'm recording this, so just that's why I'm turning your cameras off as you join. So if you look at H1, all right, my arrow's pointing to it, hopefully you can see it. The distance from, all right, so let's explain what these points are first. So A is the center of this circle, where C is a point on the circle. So like CA is a radius. So like CA is always going to be the same distance, all right? Then if we look at A to H1, all right, so what's H1? Well, I guess we got to talk about point D first. So A is the center of a circle, C is a point on the circle, D could be anywhere outside the circle, all right, and it'll make a hyperbola. If it's inside the circle, it won't make a hyperbola, it'll make an ellipse. So when like the two focal points are inside the circle, you make the ellipse. And when it's outside the circle, you get a hyperbola. So point D is just a point. And then we have the distance from A to point H1 is made up of the radius, like AC, and then you also have this other distance from C to point H1. Now, if you take point C, like no matter where you put it on the circle, the distance from C to D, if you draw the perpendicular bisector through that segment, then H1 is like a point on your perpendicular bisector. So that's going to be the same distance from C as it is from D. So like notice how like those two segments with the two tick marks, they're always the same length. And if you look at the distance from D to H1 with that two, oh, I got someone. All right. Which, anyway. So from A to H1 is made up of the radius AC and then C to H1. Now, C to H1 is the same distance as H1 to D. So if you like constantly move this point around the circle, the distance from like H1 to D and from H1 to A, if you subtract those two distances every time, so if I draw on the screen for a second, you take this distance and then subtract this distance, you're left with just this part. And no matter like where you move this point around the circle, like the difference of those two distances is always going to be the same. And then H2 is just all the points of H1, but like just reflected over a vertical line. So the way you make a hyperbola is very similar to an ellipse. It's just instead of adding the distances from each point on the hyperbola to the focus, you subtract them, and that's always going to be the same amount. All right. Now, I will never give you like a test question on that. I just feel like I have to try to explain like where these things come from. So now you know how these are created. So like if you take like a random point right here on the hyperbola, the distance from there to this focus minus the distance from there to the other focus, whatever that difference is in those two distances is always going to be the same thing. Oh, then I'm going to do that. All right. So just a couple vocab terms. So there's a lot going on this sheet, on this page here, but just want to go over some vocab. So a hyperbola has a center. So the center isn't on the hyperbola. It's like right in the middle of it. So the same way we find the center in a circle and in an ellipse, we're also going to find the center in a hyperbola. So like if it's in standard form, whatever you subtract from x is the x coordinate of the center, whatever you subtract from y is the y coordinate of the center. All right, then you also have two different types of axes. So you have what's called the transverse axis. All right, that could be horizontal. Someone's joining, I gotta let him in. That could be horizontal or vertical depending on which hyperbola goes. So like this length, we can find from the equation. And then if you double it, that whole blue line is called the transverse axis. All right. Then we can also use the equation to find this distance from the center to like this point on top of our box, which is called the co-vertex. All right. So that axis is called the conjugate axis. So the conjugate axis could go up and down or left and right. What makes it the conjugate axis is that it's not the one that's connected to our hyperbola. So it goes like in between our hyperbola. All right, the hyperbola is right here. So I probably should have done that first. But like this is the actual graph of a hyperbola. So when it says graph of hyperbola, you're going to graph this dotted line box and also the dotted diagonal lines, which are asymptotes. And then that helps you graph the hyperbola. All right. The focus or the two foci, they're always going to open up into the hyperbola. And we'll explain how to find that. And just like an ellipse, it's going to be c units away from the center. All right. If we look back at the blue and the orange lines, like the number under x squared, if that's a squared, and we call, so therefore we take the square root of that to find a, like a is the distance from our center to our vertex. And the vertex is the point on our hyperbola and also on this dotted box. So like when we graph a hyperbola, we're going to like find the two vertices by going from the center and moving a units left and right, if we know it opens up left and right, and then move from the center up and down b units, and that helps us find our co-vertices. So the co-vertices are always on the conjugate axis. They both start with the same two letters, co, C-O. And then the asymptotes, we're going to graph those two. And once you make this box, and I'll explain how you do it, you just put dotted lines like through the corners of the box. So they're the diagonals of this rectangle. It looks like a square right now, but it's usually going to be a rectangle. And that's how we find our asymptotes. And the asymptotes kind of show like how either wide or how like curved our hyperbola is. So if you have like asymptotes that are like really narrow, then our hyperbola is going to be like, it's going to be like more curved like that. But if we have like asymptotes that are like more vertical, right, then our hyperbola will be like much more open because it's going to get like closer to the asymptotes like as we approach it. All right, so we're going to look at all those things. I just wanted to familiarize you guys with this vocabulary. All right. So the middle, we start at the center, we move left and right to find the vertices. The thing connecting the vertices is the transverse axis. Then we move up and down, sometimes left and right to find the co-vertices. I'll explain how to know which way it opens. All right. Then we draw diagonals through these boxes. Those are our asymptotes. All right, we can find our focus, put it right in the middle of the hyperbola. And then once you have everything there, you just graph it. And I know this seems like a foreign language right now, but I will promise I'll go through everything, like how to find each thing. And you'll see it's not that bad. So like I said, hyperbolas can open up left and right or up and down. Just keep in mind that the transverse axis is always the one that connects the hyperbola. So like in this case, it's left and right. All right, in this case, oops, I don't know how that happened. It's going to be up and down. So this would be the transverse axis. The conjugate axis, that's the one that goes in between the hyperbola. So it'll look like that. Vertical, if the hyperbola opens up left and right. If it opens up and down, then it's horizontal. And then the focus is always inside the hyperbola. So it's like Pac-Man, the hyperbola like eats the focus. And the vertices are always the one on the hyperbola. All right, the co-vertices are going to be like here and here, or this would be the co-vertices. It'd be somewhere in between the hyperbola. And if you can graph an ellipse, you can graph a hyperbola. All right, so this is the standard form of a hyperbola that's horizontal. So notice when it's horizontal, it goes x squared minus y squared. All right, I'll come back to this slide, but if I jump to this slide, notice how in the picture, the hyperbola moves up and down. So that's going to be y squared minus x squared. So the first thing you want to notice in a hyperbola is in the equation, if it's in standard form, is it x squared minus y squared, or is it y squared minus x squared? All right, that will tell us which way it opens. Then you could find the center. So H and K tells us the center. So that'd be our center. And then the number under x squared is going to tell us how much we're moving left and right, which makes sense because the x-axis goes left and right. So whether the x squared, it's x squared minus y squared or y squared minus x squared, the number under x squared tells us how much we move left and right to find either our vertices or our co-vertices. So you take this number a squared, you take the square root of it, that's a, all right, and then you go from the center, you move a units to the left and a units to the right. And if it's x squared minus y squared, those are going to be our vertices. If it's y squared minus x squared, that's going to be our co-vertices. Then you could look under y squared, and that number b squared, you take the square root and find b. All right, then you're going to move up and down b units from the center. All right, and then if this is a horizontal hyperbola, then those will be our co-vertices. Then once you have those 5 points, so the one in red, the two in purple, and the two in green, then what you would do is make a box, like a dotted line that hits all 4 of those points other than the center. And once you have this box, then you could find your asymptotes by drawing a diagonal line through the corners of the box. So once you have those asymptotes, then you take your vertices and you draw the hyperbola to go through the vertices, but get like infinitely closer to the asymptotes. So depending on like where the asymptotes go, like that's how like wide or how narrow you want your hyperbola to be. And to find your foci, all right, use the Pythagorean Theorem. All right, a squared plus b squared equals c squared. Where like this is a, this is b, and then this hypotenuse of this right triangle, this distance is also going to be like how far away your focus is from the center. So if you just remember a squared plus b squared equals c squared, and you could think of it as like in an ellipse, this equation would be x squared plus y squared, and this equation would be minus if it's an ellipse. So when it's a hyperbola, you subtract in the standard form, but when you're finding the focus, you're going to put a plus sign there. Hopefully, maybe that'll help you remember it. But, everything that we do is going to be open notes. So as long as you just keep track of this, you don't have to memorize it. All right. And then same thing, if this opens up vertically, all right, what are you subtracting from from X, that's the X coordinate of your center. What are you subtracting from Y? That's the Y coordinate of your center. All right, what's the number under Y squared? All right, you take the square root of that, we could call it B. All right, you move up and down B units, and now these will be our vertices. So B units above and below the center. Then you could look at the number under X squared, all right? X axis left and right, X coordinates move left and right. So the number under X squared tells us how much we move left and right. So we take the square root of A squared, we get A, move A units to the right, A units to the left. All right, now you have those 4 points, you make your box. So make a box going through those 4 points. Then draw the diagonals of those boxes. So draw lines through the corners of the box. And then once you have that box with the 2 asymptotes, now you could just sketch the graph of the hyperbola. All right, so the asymptotes, it's important to find the slope because it'll tell us like the shape of a hyperbola is always going to be plus or minus b over a, where b is the b squared is the number under y squared in the equation, and a squared is the number in front of x squared in our equation. So we'll do a couple examples here. So you could click on the link and try this. Well, actually, you just look at mine. But yeah, you could click on the link and do this on your own too if you want to play around with this. But all right, so notice in the equation on the bottom right of the screen, it's x squared minus y squared because it's a horizontal transverse axis going left and right. If I just click this box, now notice how the equation is kind of hard to see. But notice how the equation is now y squared minus x squared. So that's the first thing you should notice. Then whatever you're subtracting from x is the x coordinate of your center. So if it's like x minus 2 squared, all right, the x coordinate of our center is at 2. So we just find the center first, and we find it just like a circle and an ellipse. Whatever you subtract from y is the y coordinate of our center. All right, even if it's, notice how if I switch this, all right, if I do it like this, like it's x minus -5, y minus 1. So the center's at -5, comma 1. If I switch it to be a transverse vertical axis, like the 1 and the 5 switch positions, but it's still y minus 1 and x minus -5. So the center is still at -5, comma 1. All right, so don't be confused. Don't just think the first number you see is the x coordinate of the center. It's whatever you're subtracting from x is the x coordinate of the center. Whatever you're subtracting from y is the y coordinate of the center. Then as you increase the number under x squared, notice how that red line gets longer. So that's the red dotted line is half of the transverse axis. All right, the transverse axis technically goes all the way from here to here, and the conjugate axis goes from here to here. So the number under x squared will change that. So if you were graphing this, you would see the 6 squared. So you go from the center, you move 6 units to the left, 6 units to the right to get these 2 points, all right, assuming you found your center first. And then look at the number under y squared, that's 4 squared. So you move up 4 units and down 4 units. Then you could draw a dotted line through those 4 points and a dotted line through each diagonal. And those are your asymptotes. And then as long as you have your vertices, so you know it's x squared minus y squared, so these are our vertices, then you could draw curves through them. And now you got your hyperbola. All right, so if you want to play around with this a little bit, you have the link in the notes. And if I don't change any of these values for A, B, H, or K, notice how when I flip this around like this, okay, it changes the values. All right, so that's annoying. But my point was going to be like, if you only switched around like the x minus -5 squared over 6 squared minus y minus 1 over 4 squared, if you just switch those two, then like the box wouldn't change. You would just, the hyperbola would be above and below the box instead. All right, so let's just do one together now. So everything that I kind of just highlighted are in these notes. So you can look at the PowerPoints or look at these. All right. So hyperbola is a locus, so that's a fancy word for set of points. A plane whose distances from two fixed points differ by a constant. All right, so we talked about that first by looking at that first GeoGebra, by seeing that that distance, the difference is always the same. So if it's x squared minus y squared, it's horizontal. If it's y squared minus x squared, it's vertical. So the first variable will determine whether it's horizontal or vertical. So we'll practice that in a second. H and K is the center, just like a circle. So the endpoints of the transverse axis we saw earlier, those are called the vertices. So those are the actual points on our hyperbola. So if it's a horizontal hyperbola, they'll be left and right in the center. If it's a vertical hyperbola, it'll be above and below the center. Then the endpoints of the conjugate axis are called the co-vertices. All right, so foci, so the formula to calculate C is going to be C squared equals A squared plus B squared. So if you have the standard form of the equation, you could literally just add the two numbers under x squared and y squared, add the two, not subtract, and then take the square root of that. All right. The foci are the units on the transverse axis that are C units from the center. So they're going to be on the same axis in the direction that the hyperbola opens. So kind of like Pac-Man, like if your hyperbola opens up like this left and right, then your foci will be here and here. If your hyperbola opens up and down, oh, it looks like a sad guy. I didn't mean to do that. All right, looks like that. There you go, my new cartoon. All right, so take a few moments and for these five, just like decide whether they're horizontal or vertical. And then I will write on my screen which one's which. I'll give you like a minute to try that. So all you gotta do is write horizontal or vertical. All right, so all I gotta do is tell whether it's x squared minus y squared or y squared minus x squared. So this is x squared minus y squared, so it's gonna be horizontal. Number two would be vertical, because it's y squared minus x squared. Number three would be horizontal, because it's x squared minus y squared. And then the last two would be vertical, because it's y squared minus x squared. So so once you have your direction that it opens and the center, all right, then everything after that is pretty much like an ellipse until the very end. So let's do an example. Enough talking about this. Let's just do it. All right, so example one, identify all these things. All right, so identify the center. So I like to graph this as I go, but I like to find the center first so I know where to graph it. So the center is going to be at -3, 5. So I'm just going to put the center. This is kind of fancy, but I'm going to put the center right in the middle of my graph. That's going to be -3, 5. And then I'm going to draw my axis so that I maximize the space I have. So if that's -3, then my y-axis should be 3 to the right of it. And if that's at 5, then my x-axis should be 5 below. So 5, 4, 3, 2, 1, 4, 3, 2, 1, 0. Okay. All right, that's a fancy math teacher trick for you. Draw your axes second. So now we got enough room to do this. All right, the length of the transverse axis, length of the conjugate axis. You know what, let's just graph it first and then we'll do all that. So how are we gonna do that? So first, after you find your center, look at the number under x squared. So it's 16. So we'll call that a squared. So that implies that a is equal to 4. So we're going to start at our center and move 4 units to the right and 4 units to the left. All right, so since it's x squared minus y squared, and it's going to open up horizontally, I know those are going to be my vertices. So those are going to be points on my hyperbola. Then look at the number under y squared. So we'll call that b squared. All right, that's 2, which means now I'm going to look at my center and move up and down 2 units. Okay, so now I could answer this question if I wanted to know the length of my transverse axis. Since it's opening up left and right, it's going to be 8. It's going to be 8 units long from there to there, because you got 4 over here and 4 over there. So 4 and 4 is 8, so that's the length of my transverse axis. And then my conjugate axis, well, I move up 2 and down 2, so that's 4 units long. All right, calculate C. We'll come back to that. All right, now let's graph our hyperbola. So once you have those 4 points, what you're going to do is make a box around those 4 points. All right. And I like to make it with a dotted line when I'm doing it by hand, but it's kind of draw a dotted line right now on this. Then you're going to draw dotted lines through the diagonals of this box. And those are going to be your asymptotes. Okay. And then you just graph it. You just sketch the hyperbola. So it's going to look like kind of like 2 parabola, you know, in the direction that it opens. So since it opens up left and right, I'll use the red points as vertices, and it's going to get closer and closer to the asymptotes. All right, and that's the sketch of our hyperbola. All right, very similar to drawing an ellipse. All right, if we shift gears for a second. All right, if I said graph this equation where it's the same equation, but I changed this minus sign to a plus sign, then you know, we would still use those 4 points and it would just look like that. All right, it would just go through those 4 points in green and red. So that's why we do this right after ellipse. It's very similar setup to when you're graphing it. All right, now calculate C. All right, that's so let's erase the plus sign there. All right, so for C, we're just going to use the Pythagorean Theorem. Oh my goodness, it's hard to draw on this. All right, so for C, all right, for hyperbola, we use a squared plus b squared is equal to c squared. So a squared is a number under x squared, so we could just say it's 16. And b squared is a number under y squared, so that's 4. So what you could do this real quick is just look at the equation and like add these 2 numbers. You get 20. Then take the square root and you get root 20, which you could simplify, and you should. It's always good to simplify these to 2 root 5, because the square root of 4 is 2 and the square root of 5 is 5, and 4 times 5 is 20. So root 4 times root 5 would be root 20. So the foci are going to be like here and here. And specifically, like to find those points, all right, you just take the center, so -3, 5, and then but add the C unit to the center if you're going to the right, and then or subtract it if you're going to the left. So those are our 2 foci. All right, and it's just adding and subtracting C to the center in the direction that it opens. So there's that. So identify the vertices. So we already did that. We just have to like write the points. So the vertices were in red here and here. So that's 4 units away from the center, left and right. So if we add 4 units to -3, 5, we get 1, 5. And if we subtract 4 units, we would get -7, 5 from the x coordinates. All right, the co-vertices, they're right here and here. So I'll draw that since I have room right in the graph. The center was at -3, 5. So you take the center, and since it's up and down from the center, we add b, which was 2, to the y coordinate in the center. So 5 plus 2 is 7. So it's at negative 3 comma 7. All right, and then 5 minus 2 is 3. So it's negative 3 comma 3. And we got our foci already. That's already in purple. And then the equation of our asymptotes, it's best to just use point slope form. So point slope form, remember, is y minus y1 equals m times x minus x1, where x1, y1 is a point on our line and m is the slope. So for the point on our line, we're just going to use the center because both of our asymptotes go through the center, and that's always going to be true for a hyperbola. So the equation of the asymptote is going to be y minus 5 equals the slope times x plus 3. Now to find the slope, you just look at a and b, because if you look at the asymptote, what did we do to draw this line? Well, we drew it through the diagonals of the box. So we drew it through like the center and this point. So the slope of this line would be either, for going to the positive slope one, we move up 2, and then to the right 1, 2, 3, 4. So up 2, right 4. So 2 over 4 reduces to 1/2. Right? Or if we do the other one, now we're going down 2 to the right 4. So it could be positive 2 over 4, which is 1/2, or negative 2 over 4, which is negative 1/2. All right, so you can write both equations of the asymptote like as one, as like y minus 5 equals plus or minus 1/2 times x plus 3. So some new things, but a lot of just similar stuff as what we've been doing. So if you've been keeping up with everything, hopefully this doesn't seem too foreign. It's very similar to the setup of an ellipse, just now it's a hyperbola, because now we're looking at the difference in our distances from the foci is always the same versus the sum. And just to point that out before I erase this, if I gotta find a color I haven't used yet, I don't know, I guess red pops. So if you take like this point, all right, from that point to that focus and that point to that focus, if you subtract the length of the two red lines, it'll equal the same thing as if you took another point on the hyperbola and went to each focus and subtracted those. It would always be the same. Just like in a circle, the radius is always the same. That difference is always the same. All right, so there's that. What I'm going to do is hit print screen, and then I'll add it to these notes here. So if you want to just look, I mean, I'll post this video when I'm done with it, but if you want to just refer to something for an example 1, it's all right there. All right, so let's do example 2. Okay, example 2. So we got to find our center first. So let's use that math teacher trick. Let's just put it in the center of our screen. Okay, so that's going to be at 3, negative 6. All right, so this is a vertical hyperbola because it's going y squared minus x squared. So it's going to open up like this, all right, generally speaking. So now notice like the 6 comes first. So because it's y minus negative 6, like that's still going to be the y coordinate of our center. All right, x minus 3 implies that 3 is the x coordinate of our center. All right, so now we could draw our x and y axis. So since that's at 3, I'm going to put the y-axis 3 units to the left of it. And then since that's at negative 6, I'm going to put the x-axis 6 units above it. So 3, 6, boom, will look like that. All right, so good math teacher trick there. All right, so now let's draw our box. So I look at the number 1, all right, that's under y squared. So like, I don't care if you call it A or B, and I don't mean to be confusing. So that's why if you notice, I always say like, I don't refer to it as A or B. I say the number under y squared, the number under x squared, because that makes more sense to me. The number under x squared is 1. The square root of 1 is 1. Let me start again. The number under y squared is 1. The square root of that is 1. So since it's under y squared, we're going to move up and down 1 unit to find our vertices. So it'll be like right there and right there. And I know those are our vertices because it's y squared minus x squared. So it's going to open up and down. So the vertices are up and down from the center if it opens up and down. Previously, they were left and right because the hyperbola opened up left and right. So those points are going to be at 3, -5 and 3, -7 because we just add and subtract 1 from the center. Okay, then we got the co-vertices. So since the number under x squared is 36, all right, we're going to move 6 units from the center left and right to find the co-vertices. So we go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so those co-vertices, let me make sure I'm pointing to the right thing. All right, so that would be if the center's at 3, -6, we're going to take 3 and move to the left 6. So subtract 6 from 3 and we get -3, but it has the same y coordinate as the center because it's on the same horizontal line as the center. Then the other one would be at 3, -6, but to the right 6 units. So add 6 to 3, you get 9. So it's at 9, -6. So now you got those 4 points in yellow and in red. So now we make a box through those 4 points. And that's going to help shape our hyperbola. So since the box is very wide, but kind of short, but it's opening up and down, our hyperbola is going to be very wide. All right. So to help us draw that, we're going to now draw the asymptotes. So that would be like through these 2 diagonal. So one of them, oh no, I made it so long, will look like that. The other one would look like this. Okay. So if we wanted to sketch this graph, we could. We would just start the vertex and then just make it go closer and closer to the asymptote, which is really hard to draw with this zoom tool, and probably not easy to draw with a regular pen and paper either, but it's going to look pretty flat because of the way the asymptotes are. The asymptotes have slopes that are pretty close to 0. All right, so now we got our picture. We sketched the graph. All right, we got to calculate C. So C squared is equal to A squared minus B squared. So C squared would equal 37 because A squared is 1, B squared is 36. So C is equal to root 37. So if you look at the center, since the hyperbola opens up and down, the focus is going to be above and below the center. So like one will be here and one will be here. And the specific points for those would be at 3, -6 plus root 37. Or 3, -6 minus root 37. So we got that. We got our co-vertices, we got our vertices, we got our focus. We found C. All right, last thing is just equations of the asymptotes. So if you use point slope form, all right, it's always going to be y minus the y coordinate in the center equals the slope. I'm going to skip that for a second, times x minus the x coordinate in the center, because the asymptotes will always go through the center. And point slope form means you plug in a point and you plug in a slope. And then, so we plugged in our point because we know that point's on the asymptote. Now our slope is just going to be, in this case, A over B, because now it's a vertical hyperbola. So like from this point, you can't really see it, but like from this point to this point, 2 points on our asymptote, we move up 1 to the right 6. So our slope is going to be 1/6, or for the other asymptote, it'll be -1/6. So you can add the plus or minus. And now those are the equations of our asymptotes. Y plus 6 equals plus or minus 1/6 times x minus 3. So that's really two equations in one. It's just the only difference between the two is one has positive 1/6 as the slope, one has negative 1/6 as the slope. So we can write them, we can just write it as one equation like that. All right, so I will copy and paste this too. Print screen. Erase. Make a new slide, and then you got the two examples right here. Okay, so there's 3 more examples here. All right, next class, I would like to start at example 5. So I'll start by answering questions, go over example 5, and then these 2 examples, and then we'll do more practice next class. So for the rest of this class, so hopefully you don't have any homework, I just want you to finish examples 3 and 4. And then what you need to do is just take a picture of it and upload it. And then you'll get credit for this period. And then the next class, we'll do more practice. Now, I'm not going to leave the Zoom. I will happily go through the next 2 with you. But if you feel like you can do this on your own now and you just want to do 3 and 4 on your own, go for it. But I want you to check your work. So the last thing I'm going to show you is how to graph this on the TI Inspire. And it's pretty straightforward. You just type it in. So for examples 3 and 4, do it by hand and then check your work, or just stay in the Zoom and then I'll just go over them with you. But if you ever want to know how to check these on the calculator, all right, open up a new doc, open up a graph. All right, now, right now it's asking you to graph a function, but this is not a function. Yeah, it's definitely not a function. So it's a conic section. So there's a way you to type in conic section. So you could go menu, graph entry edit. So we're changing it from a function to a that's the other class I'm doing, equation. And then if you go to equation, you'll see all the conic sections. So you can even do this for circles and ellipses too. If I didn't show you that already, that's my bad. So you hit hyperbola, and this is east and west, means left and right. And then so it'd be x minus 0 over 3 squared because it's a 9. And then y plus -1 because it's y plus 1. And then over 5. And then compare that to your graph. And if you don't have a TI Inspire, you can also do this on Desmos. And for Desmos, you could just type it right in. Like you could type in over here, you could type in like x squared divided by 9 minus y minus plus 5 squared over whatever that number was. 25, that was a plus 1. And then equals 1. And then so another way to check your work. Now you can't check everything. You can't check the focus. You can't check like the asymptotes, but you could like graph the asymptotes. Like this would be y plus 1 equals 5 over 3 times x. And so if that's one of your asymptotes, you could tell that it works because like the hyperbola is getting infinitely closer to it. And then the other one would be at y plus 1 equals -5/3 times x. So like you can also check the asymptotes by graphing them and seeing if they look correct. But co-vertices, you could probably check too by like look at these points. So that's it. So like I said, do examples 3 and 4 in the next 13 minutes and you have no homework. Or if you don't do that, then just finish it for homework. And I'll sit here for the rest of the period, answer questions, and go over these. But if you don't have any questions, free to go. If you're going, have a nice weekend. That's it.